All right, I am James Bialas. I am a master's student in the School of Technology at Michigan Tech, and this is a project I'm working on jointly with Thomas Uman and Uma Repregata and Eugene Levin. We are looking at imagery either by satellite or aerial from a plane or a drone of the ground after an earthquake. In this instance, we're looking at imagery from Christchurch, New Zealand after the earthquake in 2011. The idea is we want to rapidly classify all the damage in the imagery so that we can direct either emergency services or just get an assessment of how much damage has occurred after the earthquake. Previous results have typically looked at just a pixel-based classification where you consider each individual pixel and try to classify it as either damage or building or vehicle or water or trees. That has a problem. That works great when you're dealing with low resolution satellite imagery where everything's where a single pixel can represent up to 15 meters. As the spectral resolution of sensors increases and the pixel begins to represent smaller and smaller bits of information, it becomes less meaningful and you need to consider it in a contextual sense. So we break down the image into a series of objects whereby we consider not just the pixel but the object itself, and we break down the image into a series of objects, and we can look at the value of the pixel as well as the texture of the object, the shape of the object, the size of the object, and then from there we can include that information in the classification algorithm, and based on a small training sample we can then classify the entire image rapidly. Right now we're getting upwards of 80-85% in the classification of the image based on a small training data set.